All right, this lesson ends with a product rule and a quotient rule. What about when we're taking the derivative of a product? If I don't want to distribute out this product, what can I do? Well, you can take the derivative of the function f times g and then add f times the derivative of g. So if you don't want to distribute, so instead of distributing here, you could take the derivative by saying, all right, let's call this portion f. Let's call this portion f, and you could distribute if you wanted to. And we'll call this portion of function h, we'll call this one g of x. What I could do is say that h prime of x will equal the derivative of f times g plus the f times the derivative of g. Just like that. So that's our formula there. So if I wanted to write that out or use that, let's see what we get. The derivative of f here would be 2x minus 2. The constant disappears, so it'd be 2x minus 2, and then I would multiply this times x cubed minus 4 plus, and now I'll take the derivative, or I'll leave f as it is, x squared minus 2x plus 3. And I would multiply it times the derivative of g. 3 would drop down, so it'd be 3x, lose a power, 3x squared. The 4 disappears. Now we can distribute this. So here I would have 2x to the 4th power minus 8x minus 2x cubed plus an 8. Over here, we'll distribute and we'll have plus 3x to the 4th power. Whoops. Now this one here, we'll have minus 6x to the 3rd power. And finally, plus 9x squared. When I combine my like terms, we'll find out that h prime equals, I have a power 4 there. That means we have a 5 4th powers of x's. Going to 3rd powers here, I have a negative 2x cubed and a negative 6x cubed. That makes me have negative 8x cubes. For squared terms, I only have this last one there, 9x squared. I have a minus 8x and then a plus 8. That would be my derivative there with respect to x. Okay, so could I have distributed and still got the same answer? Let's check that and see. So I could have written h of x as being equal to, if we distribute this, I could have said this was 8x squared times x cubed is x to the 5th. So x to the 5th minus 4x squared. And now I distribute this portion minus 2x to the 4th plus 8x, and then positive 3x cubed minus 12. And that was by distribution. This here is by distribution. So how I got that? That's supposed to be an I distribution. There we go. By distribution. All right, now if we took the derivative of this, I would have 5x to the 4th minus 8x minus 8x cubed plus 8 plus 9x squared. The 12 would go away, and if I reordered this in terms greatest power to lowest power, I'd have 5x to the 4th minus 8x cubed plus 9x squared minus 8x plus 8, which is just as we had before. So you can see that you can solve it either way. You can use, that's called chain rule, or you could distribute and use the normal power rules that we've learned. Okay, so let's see another one here. This time I'm only going to use the one. We will call this right here the one, meaning I'm going to only use the chain rule here. That's f of x. We'll call this g of x. And so if I want to find h prime, I'm going to take the derivative of f, which would be 4x to the third power. 4 comes out front, drop a power, minus here 2x to the first power. The 2 disappears. That would multiply times g of x unchanged, x cubed minus x plus 1. And then we would add the derivative of g times f. So I'm going to first write an f here unchanged. X to the fourth minus x squared plus 2. And this would multiply times the derivative of g, which the derivative of g would be 3x squared minus 1. That becomes just a 1. The constant there disappears. So now once I distribute this, I'll be done. So I have 4x cubed times x cubed is x to the 6th power. When you multiply power to power, or when you multiply variables add together like that. So 4x cubed times a negative x is negative 4x to the 4th power. And then I would also have 4x cubed. Here I have a negative 2x to the 4th. A negative times a negative is a positive 2x squared. And then a minus 2x. Second term over here, or second factor, I should say. X fourth times 3x squared is going to be 3x to the 6th power minus x to the 4th. Here we would have minus 3x to the 4th power. And negative x times negative 1 is a positive x squared. Last set here, 2 times 3x squared is 6x squared. And then 2 times a negative 1 is negative 2. When I simplify all of this, and I will write in standard form here, I see I have a power to the 6th, to the 6th. I don't see any other 6ths. So it looks like I'll have 7x to the 6th power. This is h prime now we're finding. Let's go, I don't have 5th power, but I do have the 4th power here. Here, that's negative 6, negative 7, negative 10. Negative 10, x to the 4th power. Now let's go to the thirds. Third. That's all I have, so I don't need to underline that. Plus 4x to the 3rd. I do have some squareds. I have a positive 2x squared here. There's another one that makes 3 x squareds. Add that one in, we have 9x squareds. Minus 2x and a minus 2. And I believe that's all my terms. So that would be my derivative. Quite a derivative there. All right, now that I've shown you two, I'm going to allow you some time to find the derivative of h of x shown here. Pause the video. I'm sure you'll need more time.